by the aluminum section, ठीक है, aluminum material, and the second bar is made by the steel. It is a step bar, ठीक है. First step and the second step. There are two steps, and the load is acting at the midpoint, ठीक है, intersection of these two bars, ठीक है. The material property of aluminum is given. E is equal to 70 into 10 raised to 3 Newton per mm square, and steel having 200 into 10 raised to 3 Newton per mm square, subjected to the axial load. Okay, it is one dimensional problem, was acting in its direction only, as shown in figure. Okay, and the boundary conditions. What are the boundary conditions? The load ends are fixed. Okay, first end and last end, starting and end are fixed. Okay, this is the boundary condition. Area of cross section is given. A1 is given and A2 is given. A1 is 2,400 mm square and A2 is 600 mm square. Okay, the length of the first section is 300 mm square, and the second is having 400 mm. Sorry, not square. What are the findings? We determine the nodal displacement, stress developed in each element, and reaction force at the supports. Okay, so these are the findings. We want to find out these three things. And by using finite element method, so we can use finite element method for the solution of the problem. Okay, so this is the diagram and this is the given data. A1, A2 is given, L1, L2. The length of the element is given, E2 is the metal properties, and P2 is the force acting at the node number 2. Okay, so we, according to this diagram, we find the FD. Okay, there are two supports at the end, node number 1 at the starting, node number 2 at the middle, and node number 3 at the end. So in between node 1 and 2 there are element 1, and in between node 2 and 3 there is element number 2. Okay, so there is two reactions because the two fixed supports are there. The fixed support at the first node and fixed support at the node number 3. That's why there is a two support reactions. Okay, so this is the FBD of this diagram. It is also called as finite element model, and this is the connectivity table. The element 1 is connected in between 1 and 2. And element number 2 is connected between 2 and 3. This is connectivity table. Okay, now we start this problem, solve this problem by using the answers, APDL Mechanical. Now we proceed for the solution. The first step, go to the file, clear, start new, do not read files. Okay, yes. The second option, change job name, username. What is name? Bimetallic Step Bar. Bimetallic Step Bar. Okay, username, write down the roll number and time. Do you want to create error file or log file? Yes, I want to create error file or log file. Okay, okay, and we go to the next step. What is third step? It is change working directory. We set your directory. So we select your working directory from this browser. ठीक है, D drive मध्ये जायचं आहे. Select your folder. HKW is my folder in which all files are saved. Next, we proceed for the preprocessor. Sorry, preferences. First is structural. What kind of analysis will be the structural analysis? Okay. Now second option in black color. Go to the preprocessor. Element types. Add and delete. Add. We select beam element. And beam element with 2 noded 188. This is a subtype of the element. So select 2 node 188. Okay. Okay. The type 1 is beam 188, but there are 2 elements, 2 different elements. So we create again add. We add same beam element and node 2 node 188. The same element we have to select. Okay. Okay. So we select type 1 and type 2. First type for the aluminum section, second type for the steel section. Okay. According to our problem. Okay. So we select aluminum for first, type 1 for aluminum and type 2 for steel. Close it. Then there is no real constant set for the beam element, so we cannot put any value for the real constants. Go to the next, model props. Go to the model props, model model. There are 4 number of red color. Model Metal model. There are two types of metals are available. First type is aluminum. We go to the structural, linear, elastic, isotropic. What are the properties given in the problem? 70 Newton per 73. ठीक है? Newton per mm square. And Poisson ratio is 0.3. Or we can assume the data is not given sometimes, so we assume the value. ठीक है? Okay. So this is the metal model number one. We create linear isotropic material. ठीक है? Go to the material. ठीक है? There is a new model. We create a new model for a steel. ठीक है? Material ID number 2. ठीक है? Okay. Now it is also similar structural, linear, elastic, isotropic. Click on the isotropic. ठीक है? Again 200 E5. The modulus of elasticity 200 E5 is given in the problem. And Poisson's ratio for steel we use it is 0.28. It is for stainless steel or steel. Okay. So this is the second model. So metal model number 1 and metal model number 2. We create two material models. First model for the aluminum, second metal model for steel. Now close it. Now go to the section. This is the metal property for steel. 2 into 10 raised to 5. And 0.28 is the modulus of elasticity. Okay. Now we proceed for sections. Go to the sections. Beam. We use beam element, beam sections, common section, ID number 1. So there are two sections. Okay. A1. A1 is the cross section of the red aluminum AL curve ALV. AL curve aluminum body. We assume that it is a square, so written height is 7. Okay. Apply, preview, mesh view. Okay. We take photo, control, hard copy, file, APG format. Okay. Okay. Now go to the common section. We take the ID number 2 for steel. So we mark steel, STEEL. Steel. What is the cross section area? Is 600 mm square. Under root of 600 mm square. So we go to the axis and write down 24.5 and 24.5. Apply, preview. Okay. The area is approximately 600.25. It is calculated because we take some decimal places, remove some decimal places. Okay. This is the second cross sectional area. Now we go to the plot control, hard copy to file. We take a photo, APG format. Okay. Now we proceed for next. There is no meshing because we create an element. We directly create an element. We don't create any body. Okay. Go to the modeling. Create nodes. We create nodes in active CS. From figure we assume that node number 1 is at the origin. This is APD. So node number 1 is at the origin. Okay. What is the length 1? What is the coordinate 2? The length is 300. Second coordinate is 300, 0. And node the coordinates are 700, 0. Node number 1 is at the origin. At first coordinate is 0, second coordinate is 0. 0. Okay. X and Y apply. Now we proceed for second coordinate 2. What is second coordinate? Distance is 300, 0. 300, 0 and 700, 0. Second node having 300, 0. Okay. and apply. For third node, it is 700 comma 0. Okay. So there are 3 points on the screen. 1, 2, 3. First at the origin, second at 300 comma 0, third at 700 comma 0. Now we create elements. Go to the element attributes. Okay. So we create two element types. Okay. We create two element types, type 1 and type 2. Type 1 for the aluminum. Okay. So we created aluminum model, type 1, and this is a metal model. We create two models, aluminum and steel. The first model for aluminum, okay, and we also create two sections, common section of the two sections, aluminum and steel, okay, and it is in the state form. Okay, we decide the attributes. These are the property of the elements. Before creating the elements, we set the property. Okay. Okay. Now go to the auto numbers, two nodes in active CS. Okay. We create only one element number one only. Okay. First and second node. We select first and node. In between one and two, the element one is there. Okay. So we select only one and two. Okay. So this is element number one. For second element, we again set the attributes. Go to the element attributes. Okay. So type 2 for element. Okay. There are two types. First for aluminum, second for steel. So we select 2. And we select metal property 2. It is stored in metal model number 2. Okay. It is stored in metal model number 2. And the section of the steel is 2. Okay. 2 is 2 steel. That is the name of the section. And it is in the state form. Okay. Now we proceed to the auto numbers, through nodes. We select node number 2 and node number 3. In between node number 2 and 3, there is a element number 2. Okay. So different elements having different colors. The first element having different properties, second element having different properties. Okay. That's why the color of the line is different. Now we apply boundary conditions. Go to the diagram. The node 1 and node 3 are fixed. Okay. These are the boundary conditions. So go to the loads, define loads, apply structural displacement on node. Okay, on nodes. So we select node number 1 and node number 3. We click on the OK. It is fixed in all DOF. All degree of freedom is fixed. All degree of freedom value is 0. Okay, all DOF is 0. And now it is fixed at node number 1 and node number 3. Okay. Now we apply load. Go to the define loads, apply structural force and moments. Okay, force and moments on node. The load is applied at the node number 2. In the diagram, the load is acting at node number 2 of 200 kilonewton. Of 200 kilonewton. So go to the नोड नंबर 2 select only node number 2. ठीक है, फक्त दोन नंबर सिलेक्ट करायचा आहे. ओके. नाउ in which direction it is applied? X direction, fx. It is 200 kilonewton means 2e5 e3. ठीक है, kilonewton में ना न्यूटन में करना होगा. We convert it into newtons. Okay. Now the force is acting at node number 2. This is the finite element model. This model is called as finite element model. After this process, it's called as pre-processing. We implement as it is. The model mentioned in the problem, we implement in the software as it is. That's why it is called as pre-processing. Now we proceed for solution. Solution, solve, current ls. Okay. Solution is done. Now close the window. Now we proceed for the results. So go to the general post processor. Okay, go to the plot control, hard copy, animate, deform results, DOF solution. In which direction force is applied? X direction. So we select UX. Okay. So this is the value of deformation. ठीक ठीक है, एनिमेशन ऑफ डिफॉर्मेशन, ठीक है। So mx indicate the maximum deformation at node number 2 because there is load applied at the node number 2. The element 1 is under tension and element 2 is under compression, ठीक है, because of the force direction is different and node 1 and node 2 are fixed, ठीक है। फिक्स असल्यामुळे there is a no displacement at node number 1 and node number 3, ठीक है। We control the animation from this dialog box. This box we control the animation. Mx indicates the maximum deformation. The value of dmx value is 0.32.34, ठीक है। So close it. We close the animation. We scroll slightly. We get a scale. At the bottom, the color combination. The blue color indicates the minimum deformation and red color indicates the maximum deformation. And the displacement value is maximum deformation is 0.23 mm. All displacement should be in mm. Now we verify the results from the problem. We solve this problem using finite method, and after solving this problem, we get value of displacement. What is the value of displacement in the problem? The same answer is there, and this is given the same answer, and this is the finite element method. We solve calculation through the APM model, so we get the same answer 0.32. 0.2325 results, ठीक है। दोनोंचे रिजल्ट आपल्याला सेम मिळालेले आहेत. इट इज मॅच विथ द आन्सर्स रिजल्ट. यू वांट टू फाइंड आउट द स्ट्रेस, गो टू द एनिमेट, deform results and go to the stresses, ठीक है। So in which direction we want to find out the one measure stresses. This is animation for stress. There is no stress data available for this problem, ठीक है। There is result. There is reaction force at the supports. Go to the list, results and reaction solution, okay, reaction solution on atoms. There are two reactions at node number 1 and there is R1 and node number 3 there is R3. So we select reaction solution. So at node number 1, so this is the reaction force, okay, it is minus, the value is very high. These are the reaction force at the support, node number 1 and node number 3, because these are the fixed supports. Take a 130 minus 130 in Newton is the force acting, reaction force developed at the node number 1 and 69. It is matches with the our. So this is the answer. These are reaction force at the node number 1 and node number 2 in kilonewton. Also find out the nodal displacement. Go to the list and find out results and nodal solutions and go to the derived solutions in x direction. Okay. So these are the deformation. Node number 1 is 0 deformation because it is fixed support. Node number 3 is also 0 deformation. Okay. But the node number 2 there is a force acting. It is 0.3232 is the displacement at the node number 2. It matches with the our solution. Okay. This is isometric view, oblique view. Okay, we select oblique view or isometric view, and now we will go to the plot control, go to the style, size and shape. Okay, we display of element on. Okay, we can click on. Okay, so this is a 3D element. Okay, it is we assume that this cross section of the beam is a square. Okay, and this cross section is also square. Okay, so this is the beam. बघूया काय होतं त्याला. प्लॉट कंट्रोल, एनिमेट, डिफॉर्म रिजल्ट्स, यूएफ सोल्यूशन, यूएक्स केला पडतो.